This is a quick introduction to Vehicle Sketchpad or VSP. Now, what is VSP? It's a simple tool for conceptual and preliminary design only. It's designed so that you can rapidly look at different vehicle concepts and designs and have the geometries parameterizable, meaning that you can change different variables and it will retain the relationships between predefined variables that are important for aircraft design. Now, it's important to realize that this is not a tool for detailed design, for CAD analysis. You'll always want to be able to go back to something like SolidWorks to do that detailed CAD, detailed finite element analysis, and other components similar to what you're going to get with that detailed package. Now, the good thing is you can take that VSP model, export it as a CAD file, and so you can use that as your preliminary CAD step as part of that. And so if you want to do some really quick geometry, like, oh, gee, I need to generate a wing and a fuselage, you can do that in VSP very quickly, then export it to CAD and generate that. Because what a lot of CAD is not good for is generating unique aircraft geometries due to the shapes of the aircraft. So several pros for VSP. One that's been developed over many years by NASA Langley, primarily NASA, the Aircraft Conceptual Design Group at NASA. Up until last year, you had to have an agreement with NASA to be able to get and run VSP and be a U.S. citizen, and now they've been able to get that approved to be open source, which is great. You can download it, it's free and all that, so that's a really important aspect of it. Runs on most platforms, so there are different versions of it you can use in Windows, Mac, and Linux. Uses XML, which means it's you can change the file, move the files from system to system very easily. Now, it is scriptable, and what that means is you can take output from another program, such as MATLAB, and have that feed into VSP, so you don't have to run the GUI on VSP. You can have the script go into that, generate that output automatically. So if you're doing a lot of optimization, you'll want to generate a lot of different conceptual platforms and designs. You can put that in as a larger program. And again, we won't be doing that for most of what we use VSP for, but it does become very, very powerful. And so it does interface with those existing design tools as a part of that. There is a group that continually updates VSP. Actually, the conference that we're at right now, NASA has put together a workshop, and so we're learning a lot about the most recent updates to VSP. It does generate meshes if we want to do CFD and some structural analysis and stuff like that as well. And of course, as I mentioned before, one of the most important aspects, it is free. Now, some of the features. First and foremost, it's a parameterized modeler. And what that means is each component, for example, the wing, is going to be defined by certain parameters that are linked by those parameter definitions. For example, we have the wing area, S, we have the wingspan, B, we have the aspect ratio, which is defined as B squared over S. So if you change aspect ratio, it'll automatically, change S and B for you. Change S, it automatically changes aspect ratio on B. So these things are linked together with one another. And you couldn't do that, for example, in a CAD program without defining what those parameters are already. I mentioned, it doesn't include that GUI, but doesn't necessarily require it. And we'll give an example of that as we go through the demo. And it is scriptable input and output, as I mentioned before as well. One of the things we use occasionally is something called Model Center, which is an optimization program which allows you to run through lots of parameters and say, okay, first, I want to look at a range of spans, for example, and generate models for certain spans and then do the analysis on that. Now, again, it does have a lot of other features. There's some standard defined elements, that comes with VSP, so you can start putting certain things in like engines and propellers, and do that very, very quickly. Like you couldn't do in a CAD program since you'd have to define those from scratch. Airfoil profiles are often pretty difficult to put into CAD programs. Very difficult to draw an airfoil because it's got a unique leading edge, unique trailing edge. those airfoils are already predefined. You can pull those out. It also computes a lot of the common aircraft parameters that we need to use for analysis, such as the entire surface area of the vehicle, which is important to calculate drag, the planform area, which is important to calculate lift. So it allows you to calculate these directly in VSP as part of the definition. It gets us defined how we typically use those in aircraft design. And there are some other things like vortex lattice solvers and other pieces. And it's always the community is always providing continual updates for these pieces, so it's always improving. Now here's a basic interface. We'll come back and look at this in a bit as well to get an idea of how these things actually work. You have your geometry viewer window over here that lets you look at the actual geometry, all the different components. You have your geometry browser, which allows you to select the different components. And then if you select one of those, it essentially lets you edit that geometry. And we'll provide some examples from that. You can see the different windows here. You can execute a lot of these and develop the aircraft built up from these different components. Now you can have different views as well, so you can look at shaded views to examine the layout, and you can also look at wireframe views as well when you're modifying the actual geometry. So I mentioned it does have various components, so it's to do some aerodynamic analysis, to do some meshing for CFD, and structural analysis. So placement of ribs and spars, determining what those loads will be able to capable of. It's a relatively simple analysis. It's not meant to be very detailed, but it does work as a first pass as to what those loads are. So here in the corner, this is an example of that optimization. So you have VSP module here. It's feeding output to several different MATLAB modules, and again that will be used to determine aerodynamic analysis, and it works very well for optimization. And it's an example from one of the VSP developers at NASA. Okay, you get VSP from the OpenVSP website. So in addition to you have to sign in so you can download it. So they do have a hangar that includes lots of additional aircraft that you can come in and investigate and download and use as essentially a starting point to work with. So one of the things we hope to be able to get out of this as you're working through your project is to be able to provide something that contributes to the hangar as well. Now, of course, going in and pulling up VSP. So here's our VSP geometry. Again, you're going to pull up the geometry browser first. So if, for some reason you don't have the geometry browser, you can go to the geometry and pull that up. And again, that's going to be the geometry over here, the primary piece that you will use. Most of these, again, we won't talk about till later in the semester when we use some of the more advanced components of VSP. Now, to add a specific geometry, all you need to do is come in and take a look and say, okay, I'm going to add, for example, a wing, add, and there it is. And there's your default wing section. And notice as soon as you add the wing, you end up with another window over here which provides your multi-section wing geometry. You can come in and edit that. And you'll notice it has various tabs as components of this. General tabs such as, I want to change the color, be able to change various other options here which we'll talk about later, we don't need to worry about yet. Things like location, so that way you can anchor this to a specific point in your geometry, as well as rotation. Symmetry, how the symmetry is actually defined, which is going to be important, for example, when you want to define something such as a tail section. So, I have a vertical stabilizer, so I don't need any symmetry, for example. Okay. I have the plan form, and this is going to be one of the most important pieces here. as well as the section properties. Now what you'll notice is when we click on this, well, let's look at the plan form first. Plan form controls the general properties of the wing. We have our wing span, okay, have the projected span, which again in this case notice that they're linked. We have the chord of the wing, and then we have the wing area. And again, notice when I change one slider, some of the other changes sliders change as well. That is because the area is a function of the span of the chord. So when you change one, you automatically change the other. Now when you go to the section properties, you'll notice here that there are various sections, and you come over here and look at the various section IDs. Notice how they become highlighted as part of this. So for example, let's say, well, okay, we want to make a nice simple rectangular wing. So let's go over here to section 0 first. That's the one closest to the root, and notice since it is symmetric, all we have to worry about is changing one side, one section. In this case, what we're going to do is we're going to come over here and say, well, I want to be able to modify some of these pieces. First, let's take out the sweep. So we have no sweep on this particular section. And what we'll do is we'll make our root chord and the tip chord the same. So we have TC and RC here. And it's important to note that when you change these, it also links up. So we change the tip chord on this inboard section. It also changed the root chord on the outboard section. So again, these parameters are linked to one another. We're going to make a rectangular wing here for something like a Cessna. Okay, so in this case, so now we have our inboard section, nice square geometry there. And again, we can change how we modify these plan forms by looking at various pieces on this. We'll come back and look at that later. Let's go to the other section. So in this case, we have the outboard section. Again, we're going to come in here and say, well, we want to make this rectangular. We'll take the sweep away. So there's no sweep. And you notice since we have now a varied tip chord and root chord, there is going to be a trailing edge sweep in this case. And again, you can change where that sweep is located at. In this case, we're just going to leave it and not worry about that. Make it rectangular. We're going to take our tip chord, make that a little bit larger here, and now we have a rectangular wing. Okay, very simple wing geometry. Go over here and change the view, and notice it does have some dihedral in here as part of this as well. So we go to the next tab and say, okay, I want to change my dihedral. So here's my dihedral 1 for the inboard section, it's 0. Here's my dihedral 2 for the outboard section. Coming in, we can change that. And you notice the sliders are kind of preset based upon the geometry, depending upon what range you're looking at. I'm going to make that 0. We just come in here and enter the point, and there's our 0. Okay, view, and look at this from the top section. Okay. Again, we're going to come back over here and say, well, we need to change the span. We need to make this larger. So notice how we have different options for linked. So in the case of span, TC, and RC, we have the options to change these sections. Okay, but we don't have options to go through and change the other pieces as well, area, taper ratio, or aspect ratio. So we can come in here and choose one of these other, again, set of linked parameters. So in this case, let's do the aspect ratio, taper ratio, and span. So I come in here and change the aspect ratio. Again, note I'm just working in that section 0 right now, so it's not changing the other sections. Change that taper ratio. Again, we'll keep our taper ratio at 1 here, and I can also come in and change the span and make that shorter if I need to. Okay. Now we'll go to the out section. Again, we'll set that up. So do aspect ratio, taper ratio, and span. We'll give ourselves a little bit of taper here on this section. And there's our basic wing. Now again, what we can do then is we come in and start adding different components. Add a fuselage. We're going to go to fuselage 2. There's our basic fuselage section. So the first thing we're going to do is say, oh, that's not lined up correctly where we want it to be at. So we can come in and let's look at it from the front. Coming at the X-Form tab. Say, well, we need to change the Z location and view it from the top. And then we're going to change the X location. Okay. Again, center it up, and there's our basic fuselage geometry. Now, what you can do with the geometry is you have lots of options of coming in and looking at various sections. So you can come in and look at these different pieces and change these and say, well, what I want to do here, I want to have a box-shaped fuselage in this section rounded. Notice how it does all the fairing for you in each one of these sections. You could add another platform in here, another piece in that, and say, oh, we don't want to point there. We're going to also have a box at that particular section, and be able to change, the height and width of that box to provide you a really ugly-looking fuselage in this case. Again, the point here is that you can modify this as much as you want to do whatever you need. Now, different components then, once you get the basic geometry here, again, all it does is it takes time to go through and do the actual refinement. So in this case, let's go back to the wing section here, and we'll come in and you can add different sections on the wing. So now we have 3 sections, so I can change this outboard section here, give it a very small, oops, not the overall span, I'm going to change the section span in this case for this piece. So we want to be able to change that and then keep that span. Do this from the top here. So for this particular section, and only worry about that particular span. Okay, so change that span on that section. We can add another wing in here for the tail. We can also add different pieces such as a propeller. Add a prop on here. Do this from first go to here, move it up to the front. Okay, and say, oh, how many blades do we have? What's our diameter on our prop? Let's make it a 3-bladed propeller. Okay, come in here and view it from the front, and there's our propeller. Right, obviously not in the right location, but we'll offset it there to give you an idea of what that looks like. Now, again, the power of this is you can very quickly go through and add these components and change their geometry and make them look like whatever you want to. Now, what is helpful here is you can also add a background, so you can put an image in here as part of this and insert an image, so that way you can put a 3-view planform. And so if you want to model a aircraft from a predetermined planform, you can do that. Okay, and do that relatively quickly. So again, now what you can do is be able to come in, you go to Window, Background, you have a JPEG image, pull that up, insert that, and you can use this essentially to model your image. So what you'll note, this just serves as a background, so you have to essentially adjust your view. Best thing to do is to have the aircraft, set up left or right, so that way you have that image already set in, and then you can adjust the scale of your view that you have with the aircraft to zoom in and out, and then from that match up the geometry of what you have on the aircraft. Again, the intention of this first lesson is not to exactly generate the geometry, it's to get familiar with the tool. So if it's not perfect, that's okay. That's not the point of the actual lesson. Okay. Now all you have to do then is, once you have this and go through the process of modifying your basic geometry, it's just a matter of a few simple steps.
Ladies and gentlemen, we are experiencing technical difficulties. Please stand by. We will return to our regularly scheduled program momentarily. Please stay tuned. We expect to resume normal broadcasting shortly.
And then what we have is our final model. Okay, and you can see that process of developing that from that basic geometry was relatively simple and straightforward. And at this case, you can go through, and view this in different aspects. Take a look at your model, and there we go. Okay, so that's the basic setup of VSP. Again, I encourage you to namely play around with it. It's not a difficult program to learn, so the more time you spend working with it, the better that you're going to get at it.